Hello again, guys. In my last video I talked about Ohm's law. I showed some neat ways to manipulate it using the pie chart that I actually just learned. I wasn't really using it too much. And I also showed some simple equations and some problems that you might run across if you take your EBSCO test on the electrical side. So in this video I wanted to talk about different types of resistances and alternating current. There's three types that you need to know, and the sum of those three types is what gives you impedance. So the first type of resistances that you will find is pure resistance, and that could be anything like a light bulb to an electric heater, and similar type of loads that you might find across a circuit. The second type of is called inductive reactance, and inductive reactance can be motors, anything that uses a solenoid coil and generates its power using the opposition of electromagnetic forces and opposition of voltage, things like that. That's inductive reactance. And your third type is capacitive reactance, and that's basically what type of resistance is going across the like capacitors and things like that. And the sum of these three types of resistances is where it gives you impedance. And this is common to alternating current electricity. So I want to talk a little bit about the calculating resistance totals in series circuits and parallel circuits. So in a series circuit, we have to calculate the resistance of the total, we'll say RT. What you do is, it's real simple in a series. You just add up all of the resistances, and that's going to be R1 plus R2 plus R3, and that goes on to as many resistances are in a series circuit, R to the n. If you wanted to calculate the voltage of a series circuit, then you need to take into consideration it's something called voltage drop. And voltage drop basically is across an entire series circuit. When loads are placed in series, they experience a drop in pressure, or a voltage drop. So for example, that would be if I had I'm going to draw a circuit here. Here's my switch right here. Here's my power supply. Well, if I had a load coming off here and a load coming off here, and these electrons were, I guess I could put the switch over here, but it doesn't matter. If the electrons were moving through this power supply, right? Actually, no. Electrons move from negative to positive. The electrons are moving from this direction onwards. They were going through this load, and they were going through that load. Well, since it's in a series, you're gonna experience a voltage drop across this load to this load. So if this was a 120 volt power supply, and we'll get to that later. Let's say this had 5 ohms. We'll do it now, actually. This had 5 ohms, and this load had a resistance of 10 ohms. Well, the way you calculate the voltage drop, which we are going to use E, the voltage drop is the voltage of this guy and the voltage of that guy, and it should equal the total voltage. So E of the total should be voltage 1 plus voltage 2 in this case. So we're going to go back to using Ohm's law here, and in order to calculate the voltage drop, I need to first calculate the amperage. Now the amperage is intensity, right? The amperage should be constant throughout the entire circuit. There shouldn't be any amperage drop. There's a voltage drop, but there's not an amperage drop. So the amperage should equal I1, which is equal to I2. Okay, so we have resistance, voltage, amperage. Okay, and these are unique to a series circuit. It's important to know that this is unique to a series circuit because the rules change when you start dealing with parallel circuits. So if I wanted to calculate the amperage, well, first I need to find the total resistance. In this case it's 5 plus 10 because R1 plus R2 should be R total. So the total ohms of this circuit is 15. Okay, so we know we have 15 ohms. So let's set up our equation here. We're trying to solve for the amperage of the total. So we'll use IT is equal to, we know that there's 120 volts coming out of this power supply, so 120 volts divided by 15 ohms. Okay, and that would be 15, 30, 45, 90 would be 6, and 30, that should be 8. Should be 8 amps coming out of that. Amps coming out of this entire circuit. So that's the amperage total. Okay, now we'll write that in there, 8 amps. Okay, so what we do is we take our total amperage and our total resistance. Okay, actually no, we're not going to use the total resistance to calculate individual voltage drop across each circuit. So, but we will use our total amperage. So what we'll do is we'll take 8 amps and we'll set that equal to, we want to find the voltage drop across this load here. So that we'll call it E1. E1 over the known resistance of this load, which was 5. Okay, and if you remember back to the pie chart, if you multiply 8 into 5, that will give you the voltage. So 8 times 5 is 40. So this has 40 volts coming out of it. Volts. Okay, and for E2, we take the same 8 amps, set that equal to E2 divided by 10. So this must have 8 times 10 is 80, so this must have 80 volts. And if you add these two, 40 plus 80 should give you 120 because of the voltage drop. In other words, power leaves, electrons leave the power supply, travel through this load, okay, and after leaving it experiences a voltage drop, and leaving this load it experiences another voltage drop. So that these two should equal the total voltage of the power supply, and that's basically what voltage drop is inside of a series circuit.